All right. So do you see that this blue function is definitely a function? A vertical line only touches it once, and a horizontal line only touches it once. To find the function that undoes f, so let's say this is f, and we want to find the function that undoes whatever f does. So that undoes f. All we have to do is take points on f. So I'm going to make this a little bit bigger. Let's see if we can focus. So the point A1, B1 is on F, the point A2, B2, and the point A3, B3. Those are all on F. If I just flip their order, if I take A1, B1 and change the order to B1, A1, take A2, B2 and flip the order so that it's B2, A2, and A3, B3, flip the order so that it's B3, A3, and then connect the dots. The function that I'm drawing is the function that undoes whatever f does. And that is the entire idea behind inverse functions. Inverse functions undo each other. For instance, a function that y'all know is if we have f of x equals 4x and g of x equals x over 4. Are they doing the opposite operation?
Yes.
Yes.
Sweet. So I'm going to say these are inverse functions. Let's see. But we have to prove it. These are inverse functions. But to see that it really works, we need to find f composed with g of x, and we need to find g composed with f of x. If they really are inverse functions, both of these will equal x. So let's see. Let's start with f composed with g of x. So we have f composed with g of x. I'm going to zoom back out, I think. Okay. So f is 4x, g is x over 4, and we're going to see what happens when we compose them. So first, Oh, I remember. We put the first function on the outside. And what goes on the inside?
Four X.
Well, G. Yes,
Sorry.
that's okay. And so let's see. We'll get the formula for F is 4x, but I don't put an X. What do I put?
You put 4/x. I mean, sorry, X over 4.
Yes. And I'm going to do that in just one extra step. Now, is 4 the same as 4/1?
Yes.
All right. Can I do something here with 4/1 and x over 4? Can I reduce anything?
The fours.
Yes, absolutely. And what's left?
1/1.
Yes, which is just x. So 1x over 1 is just x, yes? And now let's do the other direction. Let's find G, it's the blue, G of f of x. And we remember f of x is 4x, g of x is x over 4. Which one goes on the outside?
X over 4.
X over 4.
Well, yes, but that's g. Yes, you're right. I just want to take it one step at a time, though. F goes on the inside. And now let's do what y'all said. G was x over 4, but instead of x, I'm going to put a big parentheses over 4. And what's going to go in the parentheses?
4x.
Beautiful. Can we reduce?
Can't read the fours.
Yeah. And what do we get?
X.
Both times. So we just proved. So therefore, F and G, oops, are inverses. Inverse functions. Let's do one more example of that. And I'm going to do the example that I have. Here. Example 3. I want to see if f of x equals x minus 4 over 5 and g of x equals 5x minus 4. I want to see if they are inverse functions. So let's see. F was green. Is F green?
Yes.
Sweet. And it's x minus 4 over 5. And G is orange. Okay, great. Well, to see, we're just going to find both directions of composition. And let's start with F first and F second, G second, G first. So it's important to me that you know how to rewrite F composed with G of X, still using F and G. Which function goes on the outside?
The F.
Good. And which one goes on the inside?
The G.
Very good. And over here, which one goes on the outside?
The X.
And on the inside?
G is 5x minus 4.
Okay, so let's see. Let's go back over here. Let's write the formula for F. X minus 4 over 5. And instead of X, what am I going to put here?
X plus minus 4.
5x minus, yes. Excellent. And let's set this one up as well. We've got G on the outside. So the formula for G is 5x minus 4. And what am I putting on the inside here?
X minus 4 over 5.
Beautiful. And let's see if these two functions start to undo each other. In the numerator of the first one, I've got negative 4 minus 4. Do the 4s undo each other?
Yes, ma'am. Oh, wait. No. They make each other stronger.
That's right. We get negative 8. So we get 5x minus 8 divided by 5. And we can't even reduce that. Over here, we start undoing. The 5s divide out. So that's a common thing with functions that undo each other. And then we've got x minus 4 minus 4. So it's the 4s that are not right. So this is not equal to x because it's equal to x minus 8. And this is equal to 5x minus 8 over 5, which is a mess. So this also is not equal to x. But how could I have changed one of these so that the pattern would work? What did we need with the 4s?
For one to be positive.
Yeah, we needed one of them to be positive. Let's make F positive. Now let's see what happens. Negative 4 plus 4. Now I have 5x over 5. And what happens?
The
Do the
5s
fives-
cancel out.
Very good. And we're left with x. What about over here? We already said that the 5s can go away. So we've got we've got x plus 4 minus 4. And what do the 4s do?
Cancel out.
That's right. So we're left with x. So here we're adding 4, here we're subtracting 4. Here we're multiplying by 5. Here we're dividing by 5. We're doing it at different levels, but I'm going to make another video for the next step this afternoon. But this is I guess it's just a fine place to stop. And I'm going to look at the questions and see which ones y'all can do. You can do questions 1 and 2 and try this 1, try this 3, and try this 4. Okay, so I'm going to add that instruction here for today's thing. So for Friday, try this 1, 3, and 4. And questions 1 and 2. Let me see if I can find y'all. I'm going to share my screen. I don't want this. Can y'all see the instructions?
Yes, ma'am.
Okay, great. So for this Friday, you're going to do try this 1, try this 3, and try this 4, and questions 1 and 2. And like I said earlier, I'm going to stay in the Zoom so that anyone who wants to can start working on these. And I'm going to stop sharing. There we go.